In this video, we're going to explore our exponents and logarithms skill set. Now, in the first two questions, we have exponential equations. And in this case, if we can get them to have the same base, we should, because if the bases are equal, then the exponents must be equal as well. So in the first one, they're both 4 to a power. So that means the exponent on the left, 3r, is going to be equal to the exponent on the right, which is negative r minus 2. That's a linear equation. We can just solve that and proceed as we normally would. So I'm going to add r to both sides to make sure all the r's are collected. So now I'm going to divide both sides by 4. Whoops. So 4's cancel. We get r equals negative 2 over 4, which is, when you reduce it, negative 1/2. In number 2, we have two different bases. So I have to think about what numbers might have 16 and 64 as powers. Now they are even, so I likely could use 2. But I also know that 16 is equal to 4 squared. So I'm going to rewrite this as 4 squared. Over here, 64, I know that 4 times 4 is 16, and I know that 16 times 4 is 64. So I can rewrite 64 as 4 to the third power. And what's up here in the exponent presently just stays with it. So I have 4 to the third power times negative 2a equals 4 to the second. So now that I have like bases, I can drop those bases. Now 3 times negative 2 is negative 6. Divide both sides by negative 6. I get a equals negative 1/3. Now, in the remaining portion of the paper, we're going to rely on the following relationship. In this section, we're going to convert logs into exponential form. So, as a real fast review, if I have log base a of b, and that's equal to c, I can convert that by taking the base, and that's going to be my larger number. What it equals is going to become the exponent, and what we are taking the log of is going to be what it equals. And this relationship will always work for us. So over here in number 3, I'm taking the log base 20, so that becomes the larger number. And then these trade places. So negative 20 to the negative second is 1 over 400. And you can double check that on your calculator. In number 4, same thing. Base 4 becomes my base of my power. Then negative 3 becomes my exponent, and equals 1 over 64. For number 5, the 3 becomes the base of the power. The 5 comes over here to be the exponent, and that equals 243. In number 6, 20 is the base. Trade places. Bring the 2 to the exponent, the 400 to the other side. Now, this down relationship between the base of the power and the base of the logarithm, as well as this x relationship between the exponent and what it equals, is going to hold true down here as well when we convert from exponential to log form. So the relationship that we're going to use is a to the b if a to the b equals c, that means that I can take log base a, that comes straight down, and these trade places. Log base a of c equals b. So that's what I'm going to do over here. Okay? The 6 just becomes the base of the logarithm. And then the 216 goes inside the log. The 3 goes to the opposite side of the equal sign. Same thing over here. 15 drops straight down. 2 goes over here. 225 comes over here. Number 9, 256 becomes the base of my log. 16 goes inside. 256 is what it equals. I'm sorry, take that back. 1/2 is what it equals, because that's what's in the exponent there. And number 10, bring down the 13 to be the base. 169 goes inside the log, and that equals 2. Okay. Any questions? You're welcome to go ahead and ask in class, or you're welcome to post to Edmodo or to Twitter, and I'll be happy to help you out. Okay? Have a good night.